In this video, we learn about the properties of modular arithmetic. So that gives you a new class called as the residues and the set of elements in that every residue class. So it is defined as a set Zn as a set of non-negative integers which is less than n. For example, if we have the elements of Z4, then we'll be having elements from 0 to 4 minus 1. So that is the set of elements. So now let us have an example, that is for example, let's take the modulo class 4. So it will have the elements from 0 to 3. So the first residue class is 0, and then comes 1, then comes 2, and the last class is 3. Okay. So now how to find out the set of elements of these classes? So it's very simple. The element, any element, when it is mod with 4, what element is it is giving? Accordingly, we'll be taking the value. So for example, let us start with 0. So 0 mod 4 is 0, and then comes 4 mod 4, and then 0. After 0, let's take with 1. So 1 mod 4 is 1 is a smaller element, so the remainder is 1 only. And then 2 mod 4, 2 again is a smaller element to 4, and so it comes to the remainder is 2, and that's why it belongs to the residue class 2. And then the 3, it has got a smaller element than 4, and so the remainder is 3 only, hence it belongs to the class 3. Okay. So next element is 4. So what is 4? When we do 4 modulo 4, what happens? How do we do it? We divide 4 with 4, and then we'll get the remainder as 0. Since the remainder is 0, this value belongs to the residue class 0. So 4. Now what happens? Whichever the multiples of 4, they all are going to give the remainder as 0. So 4, 8, 16, likewise, the class values will hold on. So then who are all the elements that gives a remainder as 1 will become the element of the set 1. Okay. So 5, 9, 17, likewise. And then who are all giving the remainder as 2, they will be the set of 2. 6, 10, 18, likewise. And then the who are all the values giving remainder as 3, then they will be giving the values as mm, residue class of 3, 11, 19, likewise. Okay. Now what about the negative numbers? The residue class cannot be a negative number, but it can hold the set of negative elements as well. So for example, we'll take minus 4 mod 5. Okay. So whether what is the value for it? So minus 4. So when it is done a minus 4 value, how we have to perform? Let us take this as a element A, and this is element K. Then in this case of situation, which we have to perform K minus A mod K. This is how we should do. Okay. So which is 4 minus 4 mod K. So the answer is 0. Likewise, we need to perform. Let us do for another example. If it is minus 7 mod 4. So once again, the inference from the previous thing, that is minus 4 mod k, is since the mod operator result is 0, then the value minus 4 belongs to the 0 residue class. Okay. Now let us do for minus 7 and 3. So k minus a, which is 4 minus 7 mod 4, and which will be minus 3 mod 4. Again we have to perform, so it is 4 minus 3 mod 4. Okay. So the remainder is coming as 1, and so this minus 7 belongs to the residue class 1. This is how we will be finding out the negative set numbers for every residue class. We'll see the next example.